Hello guys, in this video we will discuss about the quicksort. So it is also a divide and conquer algorithm similar to the merge sort. In the merge sort we divided our array into the two equal part, but there is a different technique of partitioning our array into two part. In the quicksort we choose the pivot element and we partition our array around this pivot element. Okay, and how we will choose the pivot element, it depends on us. There are many ways to choose the pivot element. We can choose the element which is present at the end of the array as a pivot element, or the element which is at the beginning of the array, or we can choose any random element which is in the array as a pivot element. So so let's and one more thing is there. When we choose the pivot element, we to try to uh, move that pivot element to the location such that the element which will be present which will be the smaller than the pivot element will be present left to it, and the element which will be greater than the pivot element will be present right of it. Okay, uh, it will clear when we will discuss the when we will clear we will discuss the algorithm, then this concept will be clear. So what I want to say is, okay, let's discuss the code, or discuss the algorithm, how the algorithm works. So let's 58 is our pivot element. So what we will do, we will having j index which is start with a 0. So these are the index of our array, and we will make another pointer such as I. This index will point this index will point to the location till which we got the element which is smaller than the 58. You understood? I mean to say that the element which will be the smaller than 58 will be pointed by I. You will get it as we will try run the code. So okay, let's do it. So what we will do, here we say our pivot element is 58. So what we will do, we check if we will check if array of j, if it is smaller than equals to the pivot, then we know that if it is smaller than pivot, then it should be to the left of the pivot. So what we will do, we will increment the pointer I, and then we will swap ai and aj. So here ai and j are pointing to the same index, so nothing will be changed. But but I is now pointing to the zeroth location. It means that up to zero location, uh, whatever the element we have are smaller than or equal to the pivot. Okay, so what we will do, we will increment the I, and and swap the ARR of I and ARR of J. Okay, and then again this thing will be happen. Then and J will be incremented. Now J will be incremented. J becomes here. Now we will check whether 12 is smaller than pivot. So J 12 is smaller than 58. So what we will do, then we again increment I, and we will swap it itself. So now 12 is swap it itself. So our array will remain same. And now again we will increment J, and we will compare the 10 with pivot. The 10 will compare with 58, then we will see the 10 is smaller than 58. Then we will again increment I, and we will swap the AI AJ. So this array will remain same. Okay, now then we will increment the j pointer. So now 43 and 58 will be compared. Now again 43 is smaller than 58. Now I will be incremented and let me give the space here. Okay. So now I again will be incremented and swap operation will take place. Okay. Now our array will remain same. Then again j will be incremented here. Now I is pointing here. Then again 54 is smaller than 58. Then again I will be incremented and AIAJ will be swapped. Then again our array will remain same. Now again j will be incremented here and the 32 will be compared with 58. Then we will find that 32 is smaller than 58 still. Then we'll increment I and then we'll swap the AIAJ. So array will remain the same. Then again j will be incremented. Now 66 and 58 will be compared. Then we will find out that 66 66 is greater than 58. So now we will not increment the I because I is showing that up to index 5 all the elements are present are smaller than the pivot element, that is 58. So we found the greater element, so we will not uh, swap it with the I by incrementing I. Okay, so now j will be incremented only. Okay, so what we will do now, 44 and 58 will be compared. Then we found that another smaller element than 50. Then what we will do, we will increment the I. Okay, then we will swap AI and AJ. Now you get that I and j are pointing to two different index. Now ij or ij will be AI AJ will be replaced. So 44 comes here and 66 will come here. Okay. Now I think you understood. Now I is pointing till index 6. Now till index 6 element are smaller than the 58. Understood? Now j will be again incremented. Now we reach to the end of the index. Okay. Now what we will do? We will increment again I and we will swap it with the pivot element, that is the end index. Then 58 and 66 will be replaced and now our array will become like this. Now our array will be look like. Now our array will be look like this: 23, 12, 10, 43, 54, 32, 44, and 50, 58 and 66 are replaced, then 58 and 66. and and what we will do, we will return this index. Now 7 will be returned from the partition function. Okay, now 7 index will be returned. So when we will come to the quick sort function, then we will find that the partition will take place at the index 7. So this is 0 1 2 3 4 5 6 7 8. So we will get the partition here. Okay, now this partition to two array, that is 23, 23, 12, 10, 43, 54, 32, 44, and 1 will be 66. 58 is at the correct position of its uh, it is correct position in its sorted order. Okay, now again this will be Now again this will run a partition function will again be run on these two array. So what will happen? Now again this thing will be run again. Now we have the pivot element as 44. And now again I will be increment start from here and j start from here. So after running the partition function, so what will happen? What will happen? 20, 23, 12 element which are smaller than 44 will be partitioned to the left array. That is 43. That's all. Now 44 will be here and 32 will also be here and 54 will be here. Now again this okay now again this will partition into two part. Now here the 32 is a pivot element. Now it will be 23, 12, 10. Okay, then 32 and then 43. Okay, now again this will partition according to the 10. So no element is smaller than 10, so nothing will be on the left array. On the right array it will be 23 and 12, and then 12 is again the pivot element. So there will be 23 on the 23 on the right array. It will be 23. So at this position we will get our array sorted. Okay, yeah. So what will be our pseudocode of this algorithm? So we will have the quicksort function here. Quicksort function. We are given array and an index that is low and high. Low is the index which is pointing to the beginning of the array, and high is pointing to the end of the array. Okay, we will check if uh, low is smaller than high, then only we will partition or run the quicksort. Then we apply the partition function like this, that we have dry run the code. We run the partition code here. So partition function will be run, and we will pass the array and the index low and high to the partition function, and then partition function will return the uh, integer that is the index to which we have to partition our array. So after partitioning, the array will be divided into the two part. Then again we have to apply the quickset to that two array. Now we get the two array. We will apply the quicksort and apply array low. One array will be p minus 1 and one array will be from p plus 1 to high. Okay, and this will keep on running. Let's discuss the code of the partition. The partition function will return an integer. So here partition function will be this is how partition function will be declared. It will get the array and it will also get the low index and high index. So I told you that pivot element I have chosen as the element which is present at the end of the index. So it will be array of high. So a pivot element will be the element which is present at the high index of the array. and I will take I index which is will point to initially low minus 1, and now we will run the loop j from low to high, and it will also increment by 1 after each iteration. Okay, so what we will do here, we will check if any element is smaller than pivot. Then we will check if array of j is smaller than equals to pivot. If it is, then we simply increment I and then we'll swap. Then we will swap ARR of I and ARR of j. Okay, and this will continue until j is not reached to the end of the index or to the high index. And after j reach to the end index, then what will we do? We will swap the pivot element with the next I. That is array of I plus 1 with array of I, because pivot element is presented array of I. So we will swap it and we simply return I plus 1. Okay, this will be the partition function. So what would be the time complexity of the partition function? So let's discuss the time complexity of the partition function. So in partition function, we are running the loop from j from low to high, and the worst case low can be 0 and high can be length of the array, that is the size, that is n. So its time complexity will be order of n. Okay, and here also uh, okay, yeah, here also what will we do, we are partitioning our array. Okay, we are partitioning our array. So there are two things. uh, in If we talk about the average case, then we will see that our array will be partitioned into the two array. Okay, and like for example, initially our length of the array was n. Then it can be happen that we got the two partition. One is n minus 3 and one is 3, and so on and so on. So in the best case or average case, this can be under log of n. So this will run in the log n times, and partition function is running in order of n times. So total time complexity will be n log n. But if we will talk about the worst case condition, for example, consider our array is already sorted. Our array is already sorted. We have element 1, 2. We have element 1, 2, 3, 4, and 5. Okay. Now we have chosen the pivot element as 5. Okay. So if we will partition this array, then nothing will be on the right array. This will be empty. Only we will get 1, 2, 3, 4. Then again 4 will be pivot element, and again it will be 1, 2, 3. And similarly this will go on. And how many times this partition will take place? This will be order of n times. So in this case, the time complexity will be order of n square, because we are partitioning the array order of n times, and our partitioning function time complexity is of order n. So it goes to order of n square. So uh, uh, This is the easiest way or a simple way that we consider the pivot element as the end of the end index element which is present at the end index. But what could we do? What could we do better than this? So we can choose the pivot element randomly of this element. So if we will choose the pivot element as a random array, so this uh, the average time complexity will be order of n log n only, because it is not because the chances of choosing pivot element as the end of the index randomly, it will be very low. Okay, so on average we will get the n log n only. But if we will choose the pivot element as the end index, then in worst case time complexity can be order of n square, because this is already sorted and we will not able to the partition the array into the two part. Okay, so this that was the only thing in the quicksort, and we will discuss the code in the next lecture. If you can write by your own, uh, I think you can write by your own, because I have discussed the code here also. You This is a pseudo code. You have to write same thing in the any language. So yeah, this is very simple. You can do it by your own. If you stuck somewhere, then you can watch the next video where I will code the quicksort algorithm.